as I mentioned earlier, you don't have to know the structures of the 20 amino acids, but you do have to look at a structure and work out how it's going to behave in a reaction. So you have to be able to, well, let's have a look at one of these. You have to be able to identify the amino group and the carboxyl group. All right, and here they are. The amino group is always where there is a nitrogen and an NH2, or if it's in water, an NH3+. The carboxyl group is the COOH, or of course that can drop the H plus in water. And once you've identified those two, you go to the central carbon between them, and then what's left is the R group. And this R group, well, it's only got CH bonds. They're not polar. This is non-polar. It will be hydrophobic. It's got no polar bonds. It hasn't got any slightly positive or negative bits sticking out. It will repel water, and therefore it will go on the inside of protein. Let's have a look at this one. So we find with this one, okay, so there's the amino group, NH2. Here is the COOH group, and then here's the R group. But the R group, oh dear, it also has a COOH group. And this one is clearly ionized already because I don't see where the hydrogen is. There's a little bit missing here. So this has got a carboxylic acid. It has got a carboxyl group. So this is an acidic R group, and that means it's going to give away its H+, it's going to produce a negative ion, and if somewhere else in the protein structure there is a positive ion, then it's going to attract that and produce an ionic bond. If it's got a sulfur in it, like this one, it's cysteine. Here's the amino group, NH2. Here's the carboxyl group, COOH. Here's the R group, and it's got my hastily made sulfur in here. If there is that sulfur, it's probably cysteine. If it's cysteine, it can produce a covalent bond with another sulfur in another cysteine, and that will hold the protein together in a certain way. So yeah, you don't have to know the 20 of them, and here they are. There's a bunch of non-polar ones. There's 5 polar ones. There's 3 that have a positive charge, and therefore they were basic R groups. There's 2, aspartic acid and glutamic acid, that had acidic R groups, and therefore give away their H+ and become a negatively charged ion. So you have to be able to analyze the R group by working out where the amino group and the carboxyl group are, and then looking at what remains. You might hear about essential amino acids sometimes. And here's the idea of essential amino acids. Some of these we have a metabolic pathway to make. Others of them, we have to get these amino acids in our diets. These are fairly important. So essential amino acids, well, we've got histidine, isoleucine. You don't have to know them, but you do have to know that an essential amino acid is one that we must get in our diet. Okay, so what we're going to look at next is how the amino acids fit together in condensation reactions and how they come apart in hydrolysis reactions.